All right, so in this lesson, we are going to factor quadratic expressions. So figure out what times what, express something as multiplication. Quadratic expressions, we know what an expression is, like expression. Quadratic, just for now, let's just think about it as to the second power. And we are going to use shortcuts this time. So I want you to look at this. So it's going to be in this form, ax squared plus bx plus c when a is 1. So basically, you're going to have x squared plus bx plus c. And that's, of course, a 1. Like I said, a is 1. So b will just be like a number. For our purposes, it'll be an integer. Like 1, 2, 3, 4, negative 1, 2, 3, 4, 0, something like that. And c will just be the same thing. Well, we'll do it like that. So that you know what to expect. Integer. So like 0, 1, 2, 3, and negative 1, negative 2, negative 3, and so on and so forth, right? But it's just going to be easier to show you. So this will only work when this is 1 right here. You see how it's 1x squared, and so on and so forth. So what you do is you go to factor, you look for a c. Remember, this is a's right here, b's right here, c's right here. Remember, a's right here, b's right here, c's right here. We want factors of c that combine to b. So I'm going to write that right here, factors. You know what, I'll write it right up here. So factors of c that combine to b. All right, so let's check this out. 1, 2, 2. Oh man, I didn't get rid of this one right here. Okay, I think I can fix this. Let's see. And I can just use black to go over it. Okay, better. Now I just need to take this back to 1 and change it. Let's use pink. So factors of c. So we have positive 24. So like 1 and 24 are a factor pair of 24, but when you add them together, when you combine them, you get 25. You want this 11. You don't want 25. So let's try a 2 and 12 give you 24. But if you look here, 2 and 12 combine to 14. We want 11. So let's try 3 and 8. Oops. 3 and 8. So I'll write this right here. This gives me 25. This equals 14. This equals 11. So this is the one that we want. 3 and 8. So put 3x and put 8x, right? Oh, my bad. That's not what we're doing. I was thinking about something else. So 3 and 8, 3 and 8, 3 and 8. So you will write it as x plus 3 times x plus 8. And it's as simple as that. 8 times 3 is 24. Plus 3 plus 8 gives you plus 11. So together, x plus 3 and x plus 8 form a factor pair of x squared plus 11x plus 24, because x plus 3 times x plus 8, oh, I don't know why I put parentheses on this last one, equals x squared plus 11x plus 24. All right, not too bad. Let's offer some proof with this, though. Let's prove that they are a factor pair. So x plus 3 times x plus 8. So x plus 3. I'm going to do a different color just so we can see it slightly different. X plus 3 times x plus 8. Remember, it doesn't matter what order we multiply in. Like, we could have put the x plus 8 over here first. Doesn't matter. X times x is x squared. X, or positive times a positive, positive. X times 8 is 8x. 3, oh, positive times a positive is a positive. 3 times x is 3x. Positive times a positive is a positive. 3 times 8 is 24. And then we combine like terms here. We're simplifying still. So x squared can't go anything, but we can put these x's together. So we get x squared plus, so positive 8x, positive 3x gives you positive 11x. Remember, we're combining. Plus 24. So we just basically prove that x plus 3 times x plus 8 is in fact x squared plus 11x plus 24, which is what we were supposed to get, what we were trying to find a factor pair of anyways. If you go up here, the x squared plus 11x plus 24, we prove that this times this is that. Okay, so let's do it again. Factors of c that add up to b, or factors of c that combine to b. So 10, so 1 and 10 will give me 11. 2 and 5 will give me 7. Okay, now this is interesting because this is 7, but this is a negative 7. This is a positive 7, this is a negative 7. But, so when you see something like this, it might be useful to be like, hey, well, I need a negative. If I make 2 a negative, so a negative, what would I need to get a positive? I could use another negative. Because a negative times a negative is a positive, but a negative combined with a negative, negative 2 and negative 5, together are negative 7. So that's the one. Right there. So I'm going to write, instead of x plus 2, I will write x minus 2. And instead of x plus 5, I'll put x minus 5. So together, x minus 2 and x minus 5 form a factor pair of x squared minus 7x plus 10, because x minus 2 times x minus 5 equals x squared minus 7x plus 10. Easy, not too bad. Now let's prove this. I won't have you prove it on every problem in your practice, but I just need to show you how the proof works really. So x minus 2 times x minus 5. You know what? We know that this is supposed to equal the expression above. Let's do it, or x squared minus 7x. I'm going to do it the other way around, just to show you that it's multiplication. Remember, you should be able to multiply in any order. X minus 5 times x minus 2 should give me x squared minus 7x plus 10. So x times x is x squared. X times negative 2 is negative 2x, so minus 2x. Negative 5 times x is minus 5x. And negative 5 times negative 2 is minus 10. Or negative 10, so minus 10. And we can't combine, but we can put those together. So we get x squared. Negative 2x minus 5x is negative or minus 7x minus 10. And that's what we got. Let's see. Not too bad. I've got a couple more just to show you some more examples. But I think you're good. I'm not sure you need like the proof. You know what I mean? Because I think you get it. So let's do, what did I use before? Pink. Okay. So before you even start, I would put that 1 there so you don't forget that's a 1. That's not a 0, that's a 1. So we want factors of c that combine to b. Factors of c that combine to b. So if we do like 2 or 1 times 12, for instance, we get 13, nowhere near negative 1. So I'm not even going to try the negative version of that. Oh, this is a negative 12. So I need to do this. 1 and negative 12. 1 minus 12 is negative 11. Okay. But that's still nowhere near. What if I do negative 1 times positive 12? So that's 12 minus 1, which is positive 11. Okay, that's nowhere near still. What if I do 2 and negative 6? 2 minus 6 is negative 4. Okay. What about negative 2 and 6? 6 minus 2 is positive 4. Okay, so that's not working. Or that didn't work. Let's try 3 and negative 4. 3 minus 4 is negative 1. Oh, I got a negative 1. That is the 1. Cool. And so I can write it as x. I can rewrite x squared minus x minus 12 as x plus 3, because it's positive 3, times x minus 4. And then y'all can do the proof. I might just fill it out for the notes. If not, I think you're fine. Let's go on to this next one. So negative 18, negative 18. So factors of negative 18 that add up, or in my head, sorry, I'm thinking of adding negatives, you know. But factors of negative 18 that combine to negative 3. Factors of negative 18 that combine to negative 3. If it makes it easier, I can do like this. Okay, so we have 1 and negative 18, which gets me nowhere near negative 3. So I wouldn't expect negative 1, or any kind of 3, so I wouldn't expect negative 1 times positive 18. I guess I can show you that part. 1 minus 18 is negative 17. 18 minus 1 is positive 17. Let's try 2 and 9. Oh, 2 and negative 9 is negative 7. Negative 2 and positive 9 gives you positive 7. Getting closer, I guess. We're getting smaller in the digits, or the absolute value, really. And then we have 3 times negative 6 is negative 3. Okay, cool. Some of you may